So this question we are addressing, let's pay attention to the important points of question. So engine of a car provides an acceleration of 2 meter per second square, and the when the distance between the two car becomes 35 meter, then the next car begins moving. So if this car begins moving first, then the second car will begin moving once the distance has become 35 meter, which means that the displacement of the first car should become 25 meter. It's starting from rest with an acceleration of 2 meter per second square. So I will calculate the time after which the second car will begin. So half into a into t square, this should become equal to 25. 10 meter distance is already there. When the first car travels a distance of 25 meter additionally, then the distance between the two car becomes 35 meter, and now the second car begins moving. So from here we get the value of time as 5 seconds. So from here we can understand that when this car would have moved by a distance of uh, for a time of 5 seconds, then the second car will begin moving and it will start with the same acceleration. Now this also tells us that if we make a velocity time graph, if we start making velocity time graph, then for the first car, let's say the velocity time graph starts from here. Okay, so once after 5 seconds, the velocity would have become 10 meter per second, and it is at this point that the second car will begin, and the second car will begin its journey from zero, from velocity of zero. So from here we can start drawing the graph of second car. Now second car and the first car will have the same slope. Okay, so we'll be drawing parallel lines now. The first car, the speed of the first car will continue to increase until it becomes 72 kilometer per hour, which is 20 meter per second. 72 kilometer per hour transforms to 20 meter per second when we convert it into meter per second, and then this value becomes constant. Okay, the second car, the for the second car, the graph will go on like this, and then again it will become constant. It will overlap with the first graph. And if we now think about the third car will begin moving once the second car has traveled for 5 seconds. That means the third car will begin its motion at 10 seconds, and the graph for the third car will be somewhat like this. So we can now follow the same pattern to make velocity time graph for all the cars. Okay, the fourth car will start moving after 5 more seconds. That means after 15 seconds, after a total of 15 seconds, and the graph for the fourth car will go like this. So this is how the velocity time graph of various cars are going to appear. Right. Now, if you want to calculate the distance between two consecutive cars, so let's try to understand. The red graph gives us the displacement of the first car from this point, the area under the red graph. Okay, and after this point, this point, actually this point should have been vertically above this point. Okay, so after this, both the cars are moving with the same velocity. So whatever distance has been achieved till this point, that same distance will be maintained. Okay, so the area under the red graph is this. Area under the red graph is this, and it indicates the displacement of the first car. The area under the blue graph is this. It indicates the displacement of the second car. The difference of these two area is this region. So this region indicates the increase in distance. Why do I say increase in distance? Because there was already a distance of 10 meter, and this is the additional distance that has crept between the two cars. So we have to calculate this area. Now this is pretty simple. This is a parallelogram. So this side is 5 in length and this height is 20 in length. So this distance, this area would be 5 into 20, which is 100 meter. So 100 meter of additional distance has kept between the two cars. Therefore, the distance between two cars would be 110 meter. So the answer to question number 26 will be 110 meter. Now, then the question says decrease during the time average rate of change in length of the segment consists. So let's try to understand this. In every 5 seconds, one car starts moving. So this car starts moving after 5 seconds. This car starts moving after 5 seconds. This car starts moving. So what is happening is that in every 5 second duration, we are losing 10 meter of stationary cars, of the length covered by the stationary car. So in every 5 second, we are losing 10 meters. That means the length covered by the stationary car is decreasing at the rate of 10 meter for every 5 seconds. That's 2 meter per second. So C option will be the answer. Okay, now the next part says that uh, uh, when brakes are applied, the cars decelerate at equal constant rate. That's the keyword here. It decelerates at equal constant rate, and the distance become 10 meter. The distance become 10 meter after the cars have come to rest. Now, what is important to understand here is that two cars were moving. Like now, let's just pay attention to the point when the two cars were moving together. So let's say at some instant, at t naught instant, brake was applied, and one of the cars starts decelerating. Okay, so this is the velocity time profile for the first car. Okay, now the driver of the second car will take some kind of reaction time, and then the next car will also decelerate with the same rate. So the velocity time profile for the next car will also be like this. Okay, what is important to understand here is that this indicates the loss in the distance between the two cars. Like the two cars were traveling with a distance of 110 meter between them. Okay, so they were traveling with a distance of 110 meter between them. Eventually, when the cars have stopped, this has decreased to 10 meter. So this area should again be 100 meter. Okay, which means that this length should be 5 second. So what we understand from this is that the reaction time, like another question could have been the reaction time. So the reaction time based on the information given in the last part of the comprehension, reaction time is 5 second. Now this slope could be anything. What is given in the question is that this slope must have a magnitude of less than 4. Okay, but any value less than 4 will still keep everything same. For example, this graph could well have been like this. Like the slope could have been much smaller in magnitude, like this. One of the car decelerated, and the other car traveled for about 5 more seconds, and then it followed the same profile. Even then everything will remain the same. Like this distance is 5, this is high, so even this area is going to remain 100. So we can decrease the magnitude of the slope to any value. Okay, like this angle is theta 1, this angle will be theta 1, this angle is theta 2, this angle will be theta 2. What we have to ensure is that tan theta should be mod of tan theta should be less than equal to 4, which means that the deceleration can have any value less than 4, and therefore all the three options are possible. 2 is possible, less than equal to 4, and 4. All three are possible. So these are the answers.